Hello, I'm here to talk about Bosun today, and thank you for giving me the opportunity to talk about this. I'm Kyle Brandt. I was the first sysadmin at Stack Overflow, the first full-time sysadmin, and now I'm the director of site reliability at Stack Exchange. We keep Stack Overflow online. And I'm also the original co-author of this monitoring system, Bosun, which I'm going to be telling you about. So what is Bosun? That's probably what we want to know. It's an open source monitoring system, and its emphasis is really on alerting. We release under the MIT license just to be permissive as possible. Largely, I like to think about it as an IDE for building alerts. So it has a typed and set-based expression language for evaluating time series. It also has a templating language that is for the notification side, and that expression language and the notification templating language tie in together. It has historical testing, which I'll show you later, which is, I think, kind of a neat feature. And it also has a dashboard for the alerting workflow. Another thing we built was a monitoring agent, which runs on hosts. It is optional. You can use Bosun without using this monitoring agent. But at Stack Exchange, we are a mixed Windows and Linux shop, so we built this agent to have both of those operating systems be first-class citizens. It's built in Go, so it's a binary that works well on either operating system. And one of the things it does, one of the design features is it looks for things to monitor more than you tell it things to monitor. So if it sees that Redis or IIS or SQL Server are on that server, it's going to start sending that information to Bosun automatically. And it also can operate in the polling mode. So for things that you still have to pull, such as SNMP from your network equipment, vSphere, VMware, and HTTP checks, it'll do that as well. One advantage of using an agent is that it can cache data or keep data in its store or queue it up when Bosun is not reachable. That's memory capped, so it's not gonna blow up and take up all your memory, so eventually you will lose data. But if you have like a 5-minute network outage, when the network restores, all the data is gonna flow back in, which is very useful for trying to see what went wrong during that outage. You don't lose the data. Its default frequency is 15 seconds for sending data, so you can call that high resolution or low resolution, but it's certainly faster than a minute and not quite as fast as a second. There are some things that are slower because it just doesn't make sense to collect them that much. They kind of run on their own frequency. We also do metadata about the metrics. So this is kind of the metrics 2.0 idea a little bit. We'll send for each metric, whether it's a series or a gauge, so you don't have to know that offhand. We'll send the unit, whether this is milliseconds or hits or hamsters. We need to know the number of hamsters. Stack Overflow is powered by hamsters running on a lot of wheels. It's not well known, but that's how we do things. And it also includes a prose description of the metric. So sometimes that's pretty straightforward, you know what it is, but often, metrics have some weird corners or things you need to know about, so that'll get included and presented in the UI. So at the time of building out a metric, deciding to collect something, someone can take some notes and let you know some of the things you should probably be aware of with that metric. So why always the building of the monitoring systems, right? Netflix says, don't build your own monitoring system, that's crazy. When we set out on this endeavor, I think we were maybe 35 engineers at Stack. We're approaching 50 now, so much smaller, so I guess we're even crazier. So I want to give kind of some of the background behind this just to frame it before I start to show you Bosun. So back to basics, why do we alert? I think there's usually two use cases. One, we want to prevent a problem before it happens. So we try to send alerts that are going to tell us about things before they really affect our users. And that doesn't always work, and sometimes the alerts are about our users are affected, so we want to be able to respond as quickly as possible. And we can't have just a room full of people staring at dashboards all day. There's too much data. It would be great. People are very good at detecting changes in data. They do this quite naturally, but there's too much data. I mean, we have a lot of users, but we're a pretty small infrastructure, and we're sending 30K metrics a second through our systems. There's just no way that can be watched. It's not practical. So for me, alerting is really about communication. We program our monitoring systems to communicate with us, and what that means is every time they do communicate with us, it requires our attention. And human attention is a very expensive and scarce resource. So what does it look like when notifications are bad and we don't utilize attention well? Well, this is kind of what it looks like, and thank you to the volunteers out there. So right outside the stage here are a few bathrooms, and this is the line of all the people waiting to get to the bathroom. And as you approach these bathrooms, which are single bathrooms, and you still might miss this. There's this nice sign there that says main restrooms located on the lower mezzanine, one floor below. So what was wrong with that? It came too late, it was too small, and this actually parallels, I think, a lot of the problems we see in alerting. So one of the things you have to ask yourself is, how does your alerting system get attention, right? There's all sorts of different ways our systems try to get our attention. At Stack Exchange, it was kind of like this, just a very high noise, low signal ratio. And another thing you can have is just kind of unclear notifications where things are muddled and you don't know what's going on and they're just telling you things and there's a whole bunch of stuff in there. And it's my stapler, the Bosun stapler, and I kept the swing line. Because the swing line stapler doesn't jam, and I told them that they should take my stapler and move my desk more time. I'm going to burn the building down. And that's what happens. The building gets burned down because you either didn't get a notification, or even more often you got too many notifications and you didn't realize that there was actually something important in there. So Bosun, what's our primary objective? The primary objective is to provide a monitoring platform that enables operators to utilize each other's attention efficiently. And behind that, spoiler, this is a hard problem, but I think most of you know that. So one of the premises that we took before building Bosun is that there are a lot of limits on automation when it comes to alerting. And I think alerts really need to be curated. It takes work. There's this idea of just taking all of your time series and putting them through a system that does anomaly detection. I think that generates too much noise. I think it's an excellent tool when used selectively, but just kind of, I think, blanketly applying it, at least this day and age, has not been super successful from what I've seen. So we focus on the interface and the tools and to enable people to be able to do this well. So kind of more belief in human than machine. And another consideration too is that all our environments are different. We may even have the same tools, but we use them differently, or they have different levels of importance. So it's hard to prescribe what alerts should be. And even my system changes over time. It's not what it was a year ago, and what was important is maybe no longer important. So it needs to be pretty flexible. And what this means is that we need to be alert developers and designers. So we code as opposed to flipping knobs, especially if you want to do advanced and precise alerting. So I think kind of the knob pressing model can work, and it's right for certain situations, but when you get into bigger web infrastructures and your alerting becomes very important, to really get the expressiveness you need, this looks like code. So breaking it down, what were the components we needed? We needed a time series database to store the data. We needed expression language so we could manipulate that data, the logic behind it, a templating language for the notifications, and just a good workflow in a development environment for this. So basically we have a database, language for logic, and a language for presentation. I think this is a really neat idea. I don't think anyone's built a computer program with these layers before. I'm pretty sure I invented it. So what happens if you don't have a time series? You live in this moment-to-moment existence where you have no context, right? So if I only have the last 5 values, it's basically like amnesia. I can't form long-term memories because I don't know what happened before. So we lose context. When we add an expression language, we get several things from that. The main thing, I think, is that we decouple our data collection to a large degree from our alerting. And that really speeds up the workflow. So when you want to change your alerts, frequently you don't actually have to go and change the data you're collecting, which can make tuning alerts and creating alerts a much faster process. Sometimes you still do, but it gets limited. And also, when you have this sort of host-based view of the world where you can't manipulate and combine things, I just don't think that maps to what our systems are in the real world. So then there's the templating language. The idea here is to provide context, right? So make the operator the bottleneck and their creativity to make informative notifications. So when you receive a notification, you have all the context you need to start making a good decision, or at least to get you going in the right direction. So you can add notes and graphs, and you can evaluate expressions that weren't even needed to trigger the alert, but do provide context to the alert. So what we want to do is just put ourselves in the position of the person receiving the alert when we write the alert. This is hard, by the way. And one of the things we have to remember is that there's always going to be some degree of context switching going on. It might not be bad, it might not be interrupting work, but I mean, maybe your operator, they're getting this alert, it's late at night, there could be a little going on. I mean, hopefully not if they're on call, but you gotta remember, this can come out of nowhere for the context that you're in. So the OODA loop, and just to make this a little fun, I'll call it the OODA loop. I don't think anyone's done that yet. Luckily I don't have to explain this because about 20 other people have, but I just want to explain how it relates to alert development. So it kind of shows up in two places. There's the receiving alerts in the action, and that kind of relates, but it also, you can think about it in terms of the development cycle. So we run alerts and we test them, we inspect the results, and then we can interpret the results, look for noise, signal, judge them, what triggered, what did it look like when it triggered, and then we can make a decision. Do we need to tune this, or do we need to ship it? And if we need to tune it, we just repeat this again within the interface. And that changes the cycle of alert development from possibly weeks to months for waiting things to happen, to minutes to hours, depending on the complexity of your alert. And then, of course, some tuning that will follow up because you're always continuous improvement, right? So how does this work in Bosun? For Bosun, the time series database, our primary one is OpenTSCB. That's what integrates best with Bosun. But you can also query Elastic, assuming it was populated by Logstash, so you can treat your logs as time series and do alerts, and then in the templates you can actually show some of those log entries. And we also have graphite support. And then the code is this expression language that we developed. The templating language is built on top of Go templates with just some extensions, so it's a lot like maybe what you'd see in any Ruby ERB files or things like this. And then the IDE UI and the alert handling workflow, which is a little bit opinionated, as you'll probably get the sense of. So let's start to get into it a little bit. I want to create alert. I usually start from one of two places. I've thought of something that might break or could go out of bounds if it's a higher level metric, or something broke and I don't want to be fooled twice, so I got to go back and create an alert. This example, unfortunately for us, was the latter, but whatever, it makes a good example. HA proxy has front ends, and those front ends have session limits, like all sorts of things, and they provide the current number of sessions and the session limit and the CSV data it's providing get statistics. So those are both sources of information. So step one, query some data. We have metrics, we have tags. We use a key value model, which is becoming quite popular, and that gives us that dimensionality to be able to trigger on multiple things. The back end will do aggregation, so if you're saying don't give me all the instances of things and you leave certain fields blank, it needs to know what do you want to do with those values. Do you want to average them? Do you want to sum them together? And then there's that series type, gauge or counter, which if it came from SCollector, luckily it's going to let you know what it is, so you don't even have to know that about the metric. And then some of the metadata I talked about, units and the prose description. So this is the interface. I'm sorry, it's a little hard to read, but so we can search our metrics, we get the current number of sessions, we choose an aggregator. It actually doesn't matter in this case because the one blank field is the same in every instance. And we specify our tags. Because of putting stars you don't see, but we have some autocomplete stuff in there that's kind of nice. You run the query and you get a bunch of results. And you can see what they look like on the graph. So one of the interesting things about all these results is that combined with S-Collector, we're going to get in a bunch of new metrics. So S-Collector is going to say, here's the new front end. I'm going to start sending data about that. And your alert said, give me all the things. So now your alert has just applied to this new thing. So you didn't have to tell it to start monitoring this new thing. And you didn't have to tell your alert to start monitoring this new thing. It all just happens automatically. So it gets rid of a lot of maintenance, and also what I found to be a frequent case for missed alerts, which is just someone forgot the step of adding something. So just automating that. We have that prose description here, kind of boring in this one. And it also starts to generate the query. So we have the first piece of our expression language generated for us in the graphing page. Step 2 is going to be to create the expression with the data. So we need to query. So the query on the graphing page helps generate that query. You don't have to go that route, but it can help. It's a nice way to get started. And then next, we try to reduce things as fast as possible. So we have series, we reduce them to single numbers, and then you can manipulate and combine those numbers. That's what this looks like. So we have our query here that was generated. And then as you see, we have these different results. So these are the tags. So this is why I say it's a set-based language. There's always instantiations of all these things that you do. Maybe it's hard to read, but it doesn't really matter. But each one of these is a thing, and so this is like the set identifier. And each set is going to have a result type. It's going to be a series or a number. In this case, it's a series. So we need to reduce it to a number. And we do that with the reduction function. In this case, it's average. You could do percentiles, maximum, which of course are the same thing. We have a whole bunch of them. And then you see we have these single numbers. So the next thing we want to do to make this interesting is start to combine different results. So we have this metric here, and I can just copy and paste it because the limit metric is very, very similar. And I divide it. So what I'm doing is I'm taking the current number of things, I'm dividing them by the limit, and I'm going to multiply it by 100%, and that's going to give me a percentage. So I don't actually have a percentage utilization metric, but I don't need to go back and collect that metric. I can just create it in my expression language. And it's going to line up all the different sets. The other thing we do to kind of help understand this a little bit is in this page, we'll show you the breakdown of kind of how the expression builds up to make it a little bit more comprehensible. But we still do have a pretty big unreadable expression there at the end when all is said and done. So the next thing we do is we go to the rule page. And this lets us use variables, and I use the term variables kind of loosely because it's basically text replacement. It's essentially macros. That's going to make it more comprehensible. And then this is also where we're going to start to build a notification, where we're going to start to make something that's going to look good to the operators and hopefully provide the context they need. So first thing, just some housekeeping. We're gonna rename the alert to be something sensible, and we'll also do that with the template. So you see we have alert definitions and template definitions, and they tie together. So I'm going to create some variables that are just going to get rid of some reuse, right? So try, don't repeat yourself. You want to be able to change things in one place. We also create current and percent. So we start to create some variables that represent the major chunks of the expression to make this more comprehensible. So we cut this out, we paste it, so now we have something that represents the current number for each instance. So like basically this is operating on each set automatically, and each one of those sets can become an alert instance if it meets the criteria. We do the same thing for limit, and then we say the percent is current divided by limit, multiplied by 100, which is now a lot more readable. You can start to see what the intent was here. And then we just say warn if the percent is greater than 80, critical if it's greater than or equal to 100. And we can see it works. And you get to see the results here. So the next thing we do is start to work on the template. And we get these template previews, and the subject isn't great, it just says normal, blah, 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 blah. So we start to make a more informative subject. And we can reference things. So there's certain variables that are exposed to the template, such as the status. And also any variables we define in alert are under that .alert.var's namespace. And we can evaluate those expressions. We can either evaluate them in the context of this instance, or we can do it globally and kind of filter after. We have a couple of options there. And this allows us to create a little bit more informative subject that says it's 0.28% and tells us what the front end and all that is. Another great way to provide context when alerts come in is write some notes. And in the notes, one of the best things to put is, this is what I was thinking when I made this alert. This is why I made this alert. So when you get an alert, you can see like, okay, so this is what the person was thinking. That's a great starting point as opposed to, why did I get this alert? Why did this person make the alert? And another thing we can do is include an expression that's going to be used to generate a graph. And a good rule of thumb here is to always do a greater amount of time than your actual expression was. So you have context, right? So you see, this is where I am now, but this is where I was. So we can build we can include templates. So templates can include other templates, and I'll show you that header template in a little bit. And then you can also start to include some tables that do the breakdown. So not only do we want to know what the percentage is, but we do want to know what the absolute values are. Like, what is the current number of sessions? What is the limit for this particular front end, and all this sort of information. And you can do some formatting, right? Because some of these are floats and you don't want to see a gazillion points. You only want to see, maybe 1 or 2 trailing decimals. Type faster. And then we can create the graph expression, and we can give it a y-axis label again, and that'll tell us what the unit is. Could have fetched that from metadata. I didn't think to do that when I was creating this example, but and then we get to see what it looks like, and we get our graphs, we get our data, and all of this. That was weird. So then this is the header that I was talking about. So one kind of nice feature is often alerts are email, right? Email is not like CSS style blocks. So something we added recently is you can add the style blocks, and it gets inline, which means it'll take all that CSS information and it'll put it as style attributes. So you can actually do CSS that works in your emails, and you don't have to repeat yourself all throughout the config. Yes. You can also build dynamic links based on the set information. So we link to some other monitoring systems, some documentations, we have some incident numbers, we link to that. And again, if you include that notes variable when you define the alert, it's going to show up in the template. We just have that conditional there. Okay, so here's one of the neat things is historical testing. Historical testing is, again, what lets you take an alert and see when it would have triggered for what sets, when it wouldn't have triggered in the past, and what it would have looked like at the time. And this is what allows you to test things before they go into production, which is pretty cool. So just continuing the example we have here, you enter a start date and a start time if you want to, and an end date and an end time. And you can select either how many times you want to run or the interval between runs. And we run this, and we're going to get this timeline tab. And we can go and view the timeline, and we can see all our different sets here, which are not readable. But as you go down, all of a sudden there's that, ooh, look at that little yellow thing. That means there was a warning, and that's what I'm interested in. So I can go and look at it, and I can see what that alert would have looked like at the time. And if I don't like it, I can go back and tune it. And as I see, it was 400,000, hard to read, but going to 500,000, so 80%. And that looks pretty seasonal, except for that little Bosun outage, which we've done some things to work around that. But this gives you context. When you get this alert, you know, okay, I probably don't have to jump on this right away, right? Because it can just shoot right off. This is just part of our normal growth, so I have to deal with it in a reasonable amount of time. So I want to talk about the workflow a little bit too. So the philosophy behind the workflow is that every alert requires action, in my opinion. That's kind of a mantra. If it was a correct alert, if it was signal, then you need to fix the problem, rather obvious. If it was a false alert, most of the time you should be going and tuning it so you don't continue getting those false alerts. Because if you don't do that, then you're going to get the noise and the alert desensitization. There's also other cases where you can get some alert noise where people forget to silence things during maintenance. The best idea I've had so far is just to beat people when they do that. So excellence in monitoring for me is really this interface between man and machine, right? Like I said before, we're programming our monitoring system to communicate with us. And so in our workflow, we have both machine states and human states. The machine states are probably pretty familiar. We have severity state, normal is all good. Warning and critical can actually be arbitrary expressions, but I like to treat them like warning is something is going to break and critical something is broken. But you could make those different degrees of badness if that's what you want to do. We also have unknown. Unknown this is largely a push-based system with those agents. So if you define an alert and you have all these sets and a set has appeared and after a little while that set is no longer there, we're going to trigger an alert and say, hey, this particular instance, I don't know about this anymore. That's maybe something you should look into, which is a very important feature of a push-based system. It's also a very annoying feature to implement. So two other states we have that are machine states are active and inactive. So active means it's still going on. Like whatever the condition is when you look at the dashboard, it is still in the state of being warning or critical. Inactive means it no longer is, but that stays on the dashboard. That doesn't get cleared. And this is where the discipline starts to come in. The idea being that just because it's no longer active, it doesn't mean you dealt with that alert. It doesn't mean you went and tuned whatever caused that alert in the first place. So that's this is where the opinionated and discipline comes in. So we also have the meat bag states, right? The meat bag states are unacknowledged, so the alert first comes in and no one's acknowledged it yet. If you want, you can set up escalation chains if no one acknowledges it in a certain amount of time. And then eventually someone will acknowledge the alert when hopes. And when they do, they can send an email and it'll say, Kyle acknowledged this alert and this is what I was thinking, this is what I was doing. So it's a way for me to communicate with the other operators, or them to communicate with me. And same with closing. When I fixed it, and you know who closed it and they can say why. So if I have a question about what they did, I can go and talk to them, or they can come and talk to me, depending who it was. So this is the dashboard, just to give you a little bit of an idea. Those exclamations means it's currently active. And when you expand something, you can see what the actual alert was that was in the email. And then we also have these incident numbers. So when you go to the incident, you can see both the machine state transitions and the human state transitions that this particular incident has gone through. So events are the machine states, and then actions are things that humans did. So now just to kind of show you some interesting alerts that we've built with this thing. So this one is about anomalous DOM rendering time by country. This one is actually maybe more interesting than just the data we collect. One of the things we do is we have a setting in our application that is a sample rate. So we'll say 3% of the people that hit our site, would you be so kind to send us your client timing? So web browsers have this client timings API built in, which says, how long did the TCP connection take? How long did DNS take? How long did SSL take? How long did it take to start painting the DOM? How long to completing rendering the DOM? So you can actually start to sample what web performance is like for your users. So in this case, we break it down by country, and we can we do it anomalously. And I'm not going to go into the expressions a whole lot. I'm more interested in just kind of showing you the result. I need to go to the slide for the results. I do not. Okay, cool. So you can see these breakdowns. We know that the country was India. They were using the questions.show route. we can start to see how long it actually took on average, or sorry, 95th quantile in this case. We can see the difference, the number of samples compared to the total number of country samples we took. And this would not actually trigger an alert, 400 milliseconds difference on the scale. I didn't have a bad performance accessible to me at the time. But at least this gives you an idea of what it would look like. And then you have the graph kind of showing what's on, and as you can see, there's a lot of noise here, so it's actually, in this case, the visualization is not super helpful. Another thing is just high CPU, right? So what we found is when we do anomalous alerts, we also tend to mix them with threshold, and when we do anomalous alerts, there's a fair amount of tuning that we need to do to get this thing to have a pretty good signal-to-noise ratio. So what we ended up saying, like, is the current median greater than the past? Is the current median greater than 30% CPU? Because I don't really need to know about changes if you're still under 30% CPU. And is the absolute, got cut off, but is the absolute difference bigger than 10 milliseconds? Because if you only change 5 milliseconds, to me, that's not worth the interruption. It's not worth the context switch at the time. Cool. Are you fine? Please put yes. And then we have the threshold detection, which is kind of like the safety net. I still want to alert if it's like above 80% or 100% in my environment. Maybe you don't, right? And that's why I was saying before that these are very, everyone's environment is different in how they handle things. Cool, that's an alert. And here's what it looks like. Again, we have the breakdowns of information that helps you know how the alert reached this decision. And then we also will show you CPU information for various processes that you've monitored for that host. Because what's one of the first questions you're going to have if you have high CPU? What's the thing using the CPU? So we show that as a way to give context. So this actually is another visualization, not super informative. The time span probably should have been longer in this case to really kind of get a sense of context. So it's pretty hard to get this right, to really figure out exactly what to do for the right thing. Disk space, what we do is threshold detection again, but we do forecasting in this case. So we do a linear regression, and we alert if you're going to be at 0% disk space in a certain amount of time based on various regressions. And I can tell you, this feels awesome. When you go to one of your developers that did a job that isn't cleaning up itself and say, hey, you need to clean up or we're going to run out of disk space in 45 days. So, what, you just predicted the future? It's like, yeah. So it's like, you don't need to drop what you're doing, but sometimes please in the next few weeks fix this problem when you have time. And that's great, because one of the worst things for an operations team is to be constantly in this reactive state. And this right here that I want to show is just, we have this lookup feature, and what that lets you do is just set different numbers based on different sets that have come. It's like a case statement. So as you have exceptions, you can add this in there to tune things for kind of your outliers and oddballs. And this is what the alert looks like. Again, these can get pretty sophisticated. We do a short-term forecast, a long-term forecast. We look at the deviation recently to see if it's still changing a lot. And then we also do some just flat-out thresholds to alert us if we've crossed these thresholds. And then as far as what the alert looks like, we get a graph of how it was changing over time. We get the breakdowns where we can see percent, absolute values, because 5% of what? How many terabytes or gigabytes is that? What are these different forecast things? How has it changed? So this was actually triggered on a forecast alert, and then it converted to a threshold, a percent threshold alert. So we'd actually need to go and probably add an exception if we're going to be below 5%, and that's why those case statements are useful. Just another type of alert is compliance alerts. These are kind of fun. You can change people's behavior with alerting. So we disable Puppet sometimes when we're working on environment. It basically says, Puppet, don't run until I tell you to run again. And we decided, people, please stop. As a team, we agreed don't disable it and don't leave a reason. So if you disable Puppet and don't leave a reason, we're going to get an alert right away that says someone disabled Puppet on this host and it didn't say why. So then we can go in the team and say, who just disabled Puppet? What's going on here? And then another thing is sometimes we forget to re-enable it. So if it's been disabled for 24 hours, we'll send this alert and say, hey, did you mean to leave this disabled for that long? And if you know you were going to do that, you could silence it. So you can reduce that noise, but most of the time it means someone just forgot. Another thing I'm not going to show a whole lot of, but so we have these sets which are tag key values. And again, to separate the concerns of what your data is and what your alert wants to be, you can actually manipulate these sets. We call it transposing. It's kind of like SQL pivoting. And the reason is, so what we want to do is we want to separate scope from alerting without having to change it. So an example at our HA proxy setup at Stack is that we have failover clusters. Within those clusters, we have load balancers. Within those load balancers, we have tiers. Those tiers are different processes, instances of HA proxy running. Within those instances, we have front ends. Front ends point to multiple back ends, and back ends can have multiple servers. So there's lots of things going on here. If you did it by host, you could have 4 possible alerts. If you did it by tiers, which again I said was what we call each process across hosts, you could do that. That's what suits your environment. If you did it by tier plus host, you would have 12. If you did it per servers, you would have all these, end servers by end backends, by end host, by it ends up being a crap load of alerts. Or you could do it based on cluster, or you could just have one for all of your HA proxy in your entire infrastructure. There's no correct answer. Again, your environment is not my environment. So there is a trade-off though. If you make a larger scope that's more encompassing, you end up including more breakdowns of information in the alert, but you get less alerts. And if you do smaller scopes, you'll get more alerts, and you don't need as much breakdowns. And the correct answer is really to find what the balance is for, in your environment, for failures, how they tend to group. Some other niches, I like that word. The interface is entirely built using the REST API. So anything you can do in the interface, you could tie into your own applications. We just like that design in general, just to separate those 2 layers. Dependencies, you can have an alert that depends on another alert. So Bosun will ping any host that it's seen, and it'll say, it'll make that a dependency for any host-based alert, so they won't trigger. And then you can, we have silencing, which is what you do during maintenance. Different notification types, doesn't have to be emails. We also have different ways to, based on the set or other conditions, notify the correct people based on what this thing is. So we have different routing options for these notifications. Alerts can run at different frequencies, so if you have things you want checking every minute because they're that sort of high importance thing, you can do that. If you have things that need to only run every half hour, like this space that's doing a lot of forecasting, you can do that. You saw that outage before, so one of the things we did is we separated the relay, because we flow data through the relay when we're using OpenTSDB to add some capability. So that's its own process. It doesn't have to be, but you can make it its own process. So if you do manage to panic Bosun by doing something crazy in our template page, because we do expose some data structures there and some Go stuff, the data will keep flowing. And we also have alert macros. So if you have alerts that have basically very similar patterns, you can put those in a macro, and then you can reference those in future alerts. So again, don't repeat yourself. Some of the things I've learned that I think are good characteristics of good alerts and good alert handling. Again, provide context. Always put yourself in the shoes of the person receiving the alert if you can. Include both small and big levels. So one thing that I maybe interpreted wrong that I don't really agree with is I don't care if just servers are breaking or just small components are breaking. What I really care about is if there's something big wrong, if there's some major problem with my business goals. I care about both, because those small things breaking are like what I like to think about as latent issues. If you don't address those are what can lead to the big outage problem that affects your business. So you really need both, but I do agree with emphasizing the big metrics, because that is what we tend to skip as engineers. It's easier just to think about CPU and memory than it is to think about our business needs. Alerts should be actionable. If you get an alert, there's nothing you can do about it. Probably not that useful. You can have some information alerts, but you need to be careful because, again, alert desensitization, if you have too many alerts that are just kind of informative alerts. They should show us something we don't already know. They should be handled, and then regular created and tuned to keep the noise down. And that's what we try to achieve with the expression language in this interface. It may look complex, but I promise you that expression language is really quite simple compared to quantum physics. So we are alert developers, and designers. The problem space is complex and varied. We have capacity planning, compliance, meta alerting, application and systems, different ways to approach it. You can use the use method, utilization, saturation, errors. It lives on that space between human and man, which is a difficult problem. That's kind of what makes us designers, to get the machines to speak to us and us to speak to the machines. Sorry, I forget the name. It requires a deep understanding of your systems to be able to do these high accurate alerts, but it also perpetuates that understanding. So when I go and I dig into a system and really create these accurate alerts that take in a lot of different metrics, I learn a lot about that system at the same time. And the result of that is that I am better prepared for the unknown unknown. So when something really goes wrong in my environment, sometimes it's simple, but usually it's many layers of failure. I have defense in depth, and it slipped through the holes, and I am now better prepared for that unknown because I spent time understanding the system more. So I don't know if I have time for questions. Come work with us at Stack Exchange, great place to work. Surprise, surprise, we're hiring people. I think we're probably the only company here doing that. I want to thank a few people. Craig Peterson, one of our recent hires, has been adding a lot of the features that you just saw. Dieter Plotting, he's out there. He worked at Vimeo, and he now works at Raintank, who you saw a presentation from yesterday. He had a graphite support and the query cache, which helped a lot. I want to thank you to my company for letting me tilt at this windmill, and my team. My team is currently moving a data center right now. Mile High Ops is the Twitter hashtag if you like hardware porn. And we like our hardware porn, like the cabling's immaculate, so that's fun to look at. Bosun.org, we have a Slack channel, Bosun.org will have that invite. And we also have a quick start guide and a Docker image so you can play with this and get it up and running fairly quickly. I have no idea where I'm at. Do I have any time for questions? No, I do not. Okay, so I'll be out there. I'll be around. If you have questions, I'd love to answer them. Thank you so much for